Question number 1 states that acid dissociation constant Ka for hydrofluoric acid at 25 degrees C is 6.8 times 10 to the power negative 4 molar. For a solution of 0.2 molar HF, calculate the concentration of hydronium ion at equilibrium and degree of dissociation. Right. So I start with the first question, 1A. First of all, this type of question, number 1 important thing is to write the equation. Okay, so hydrofluoric acid plus water, okay, this is aqueous, this is liquid in equilibrium with, okay, we must know HF is acid. Okay, so when HF loses its proton, because we know from Bronsted-Lowry theory that acid donates proton, so donates proton out, that means kita akan dapat dia punya conjugate base F negative aqueous. Ini adalah dikenali sebagai conjugate base. Okay, after losing the proton. Similarly, if that is acid, the partner must be baseline, iaitu water lah. Water mesti adalah base. Okay, and just now acid we said donates proton, so base will be accepting the proton. So accepting the proton meaning after the proton from here goes here and it accepts the proton, it become H3O plus aqueous. Okay, H3O plus aqueous. So you can see now, after the proton is donated to water and water accepts the proton, it become hydrosonium ion. So if this is a base, that means the partner kita panggil sebagai conjugate acid. Okay, clear about that? Is it clear? Okay, good. Right, now we see the Ka given. Ka is given as 6.8 times 10 to the power negative 4. Since the value given is negative 4, shows that Ka is less than 10 to the power negative 5. Okay, we can do assumption. So we can do assumption. What assumption? We look at the table. So kita buat table lah. So tulis balik HF tambah H2O, F negative, H3O plus. Table initial concentration. Initial kita dah tahu 0.2. Yang ini tak ada, ini kosong. Initially tak ada lah. Okay. Changes in the concentration. So here we have to use minus X. Sini tak ada. Plus X plus X. Kemudian final concentration 0.2 minus X, tak ada, X. Okay, can follow so far? Can boleh tengok kat Jamboard lah. Okay, so what happen, kita tulis Ka sama dengan F negatif. Pergi slide seterusnya, go to next slide. So kita ada F negatif, kemudian kita ada H3O plus hydroxonium ion, kemudian kita ada HF. So please take note, water tadi masukkan sebab water liquid lah. Right. So this is where we key in all the values. So 6.8 times 10 to the power negative 4. This is X and this is X. This is 0.2 minus X. Kan? Okay. This is the area. This is the area yang kita nak buat assumption. Kenapa kita nak buat assumption? As I said, nilai dia kurang daripada 10 negatif 5. So apa assumption yang kita akan buat? 0.2 tolak X hampir sama dengan, ataupun approximately same as 0.2. This is the assumption we are going to do. Okay, so maka kita punya calculation akan ubah. Dia akan jadi 6.8 times 10 to the power negative 4 equals to X squared divided by 0.2. Kita cari nilai X. Okay, kita cari sama-sama. Saya dapat 0.0. Kita ambil, ni soalan ada berapa 2, 3, kita ambil 3 lah. 117 X. Okay. Pelajar-pelajar semua dapat tak jawapan ni? Dapat Okay. Now the question always is, kenapa kita buat ini? Assumption. Kenapa? Atau bila kita boleh buat? When we can do the assumption. Dia ada 2 syarat Pertama, you punya KA. Oh, sorry. Oh, cannot do assumption. Sorry. Okay. Alright. This is incorrect. Sorry, because the KA is not small, It's bigger than 10 to power negative 5. So, assumption tak boleh buat. Cannot do. So, look at slide number 1. Because the KA is greater than negative 4, so, assumption ini tak boleh buat. Sorry, salah tengok. Okay, so maksudnya, calculation ini kita tak boleh guna lah. Assumption tak boleh buat, So, this one, kita potong. Kita pergi slide seterusnya. I do redo again. KA equals to F negative H3O plus HF. Okay. So based on the table, this is 6.8 times 10 to power negative 4. This is X. This is X. This is 0.2 minus X. Okay. So solve for the quadratic lah. Okay, quickly kita buat. What is the time? Okay, still have time. So I quickly do X squared plus 6.8 times 10 to power negative 4x (1.36) minus 1.36 times 10 to power negative 4, so equals to 0. x1 and x2 lah, right? 5, 3, 1, 6.8 times 10 to power negative 4, 1.36 exponent negative 4. So x1 saya dapat 0.01113 molar. X2 dapat negatif 0.012 molar. So this one we neglect lah because it's negative. Guys, dapat tak jawapan? Sorry tadi tadi saya salah buat assumption, tak boleh buat. Did you get 0.0113 x1? Pelajar lain dapat tak kuadratik tu? Dapat Okey, saya bagi tahu kenapa jawapan saya salah tadi Okey, saya terangkan di slide seterusnya lah. Kalau KA kita kurang daripada 10 negatif 5, contoh 10 negatif 6, 10 negatif 9, 10 negatif 12, right? Kurang, kita boleh buat assumptions. Okay, boleh buat assumption. Maksudnya pada delta concentration tadi kita ada 0.2 tolak X. Sorry, not delta, final pada final concentration tadi kita ada 0.2 minus X. So assumption yang kita boleh buat adalah final concentration kita adalah 0.2. Okay, sekiranya kita punya KA adalah sangat rendah daripada 10 negatif 5, iaitu negatif 6, negatif 9, termasuk negatif 5 lah, Tapi kalau kita punya KA adalah 10 kuasa negatif 4, 10 kuasa negatif 3, 10 kuasa negatif 2, dalam kes ini anda tak dibenarkan buat assumption. Jelas tak benda tu? Okay, so you faham kenapa solution pertama saya salah Slide number 2 salah. Saya letak pangkai. Dan slide number 1 betul, semua salah di assumption. Can you understand why it's wrong? Can, that is the reason why I say it's wrong, because I made a mistake by assuming the 0.2 minus x approximately same as 0.2. That is incorrect because the Ka value is large, 10 to power negative 4. Okay, so we can't do the assumption. Tak boleh buat assumption. Kalau dalam sini boleh buat lah. Kalau dekat 10 kuasa negatif 5 atau negatif 6 atau negatif 9 contohnya, you can do the assumption. Okay. Alright, that is the first thing. Second possible thing is, kalau degree of dissociation, okay, sorry, saya tulis kat sini je lah. Kita juga boleh buat assumption. Kalau kita juga boleh buat assumption, sekiranya percentage of ionization or dissociation is less than 5%. Okay, but this is the what we call the secondary factor lah. The major factor is the Ka value. Okay, ini biasanya jarang kita check. Biasa Ka value tu jadi petunjuk lah, sama ada boleh assume tak boleh assume. Biasa percentage of ionization ni kita akan tahu selepas kita kira But anyway, it doesn't make a big difference kalau you realize. Kalau saya buat assumption, jawapan yang saya dapat adalah 0.0117 kalau saya buat assumption Kalau saya tak buat assumption, saya dapat 0.0113. Tak jauh beza lah. Can you see that? Buat assumption dan tak buat assumption lebih kurang sama lah. Dia tak banyak beza lah. Okay, never mind. All this we'll practice again in the class. Okay, finally, degree of dissociation. Dia minta kira The question B asks us to calculate the degree of dissociation. So, alpha is amount dissociated divided by amount initial. Okay, so we see the amount dissociated is 0.0113. Initial amount 0.2. So, we see the degree of dissociation. Cuba kita check. I get 0.0565. Tengok dapat tak? Degree of dissociation is 0.0565. Dapat Dan degree of dissociation ni, kalau dia less than 1, menunjukkan itu adalah weak acid. Okay? That shows the weak acid. Sebab degree of dissociation tu sangat rendah, kurang daripada 1 lah. Okay, I think it's time's up. Tinggal lagi 5 minit saja. You have to go to next class. I stop here. The rest we will do practice in the class.